Hello everyone, my name is Manuel and I'd like to show you how you can write a computer language. The tools that I've been going to be using are C++. If you have any knowledge of C++, you might know that what I have right here is a string with text on it that I'm going to be passing to this function. It's called parsed. Inside the string you can see that there's a small program, not in C obviously, as the syntax you can tell it's not C or any other probably language that you know, because this is the targeting language that I'll show you how to write. Here receiving one parameter and I'm passing the number 3, and then it's going to use this count variable to increase the variable I from 0 to count, in this case 3, and then it's going to print the variable I. So the idea is that you see what are we going to be doing probably at the end of the course. So let me run it so you can see it. Since the program after execution it's printing 0, 1, 2 and 3 because it's what it says here. Another thing to notice is that there's no main or any starting point, just calling a function, very similar to a language like JavaScript. How everything works is like this. We're going to be writing a parser, which is at the end it's going to be pretty much a full compiler which will translate this source code into something that people normally call bytecodes. And bytecodes, although you create them, they similar to a machine language. And then when those bytecodes are generated, this VN, which stands for virtual machine, it's going to run the program that you saw right here. So I'm guessing you already have an idea what is a compiler, and at the end what it does is translate this into another type of language, the bytecodes in this language that I'm going to show you how to write. The thing that you're probably not very familiar is what is a virtual machine, but virtual machine is just a way of translating in this case those bytecodes into machine language that the computer really understand. The advantages of using this of a virtual machine is that if I had this virtual machine in any computer, let's say right now I have it on a Windows, but I could have it in Linux. If I compile it in Linux, the same program compiling to bytecodes will run. You might be wondering, how will the compiler understand this source code to generate bytecodes? And it's not that difficult. What it does is start reading character by character from the string. In this case, if you start with F, I'll place it right here, F, and then it will continue with U and then N. But as soon as you see a white space or maybe parentheses or one of those symbols like the equal sign or semicolon, it will stop. So if you start reading it F, U, N and find the space, you stop right there. And this is gonna be the first word, which we will call it tokens. So this is the text that you read, text. It is convenient to have something else later for a way to understand exactly what every word is. So we're going to attach something else. We'll call it type. As soon as we read the first word, I'll be calling it identifier. I will use this keyword, identifier. We'll read the next word letter by letter, starting from F, U, the other U, and then as soon as we know that the next character is a parenthesis, we stop. So we put it here, F, and this is going to be another identifier. And then we read the parenthesis. We don't care about the space, by the way, but the parentheses, they're meaningful to the language. So put it here. When we find a parenthesis, so we call it something like open parenthesis. Let me print. And then we keep going with the next word here, which is C, and then O, and keep going U, N, and T. And since the next character it's a closing parenthesis, we stop right there. So right now this count is another identifier, so we stop right there and then keep going with the next word. In this case is a closing parenthesis, so we put it here, and then after that, new line. So we start right there too. and this is going to be the close parent. So after that, we don't really care about the new line characters because it has no meaning in the language. This open curly bracket has a meaning, so we store it here. We give it a token type. Let me call it like this, curly. It doesn't really matter what naming you decided to use. And then we read for statement the same way, letter by letter. Next character, it's not a parenthesis or nothing like that, so we keep going, R, and so on until we reach the R, and then after the R there's going to be a white space, so we stop. And this is going to be another identifier. After the is the letter I, next to it is equal. We start right there too. It becomes another identifier. Then the equal, this is special type, and so on and so forth. So at the end of the day, we're going to be having a sequence of words and symbols like this. Every word and symbol will have a type. And you might be wondering, why do we care about putting a type? But the idea is that when we're going to try to make sense of every word, it's convenient to have something like this. It's easier. You'll see later on. The first thing that we're going to be doing is, I'm going to call it tokenizer, which will do exactly that, break down the whole program into small words and symbols that has meaning to the language. Thank you for watching, and see you in the next episode.